Hey folks, this is the first video of section 8.4. This is just going to be an introduction to vectors, specifically position vectors. So I will follow up with a couple of example videos after this one. All right, let's talk first of all about what exactly is a vector. So I'll point out a couple things in order or not in order. First of all, geometrically, a vector is a directed line segment. So it's a line segment, meaning it has a beginning and an ending, but it also has a certain direction. Let me show you a picture here of a vector, and let me erase my points there. It really looks like a ray. It looks like we would expect that arrow to mean that it's going to keep on going forever and ever, but that's not the case. A vector, a better way to draw it, which nobody asked me hundreds of years ago when they came up with vectors. But a better way to draw it would be to draw a line segment, because it does have a beginning and an ending, and then to show maybe the arrow in the middle that this is the direction that this line segment is going. That might be a little less confusing. So maybe you want to think of it that way. The arrow here on the end does not mean that this keeps on going forever and ever. So it's a directed line segment. Algebraically, it's an ordered pair. So we're going to be using this coordinate that is at the end of our vector. Now let's back up a little bit. A vector is a special type of vector called a position vector. Has two things that are going to be true. First of all, the initial or the starting point is going to be at the origin, is going to be at 0, 0. And it's going to, again, be called a position vector. The second piece of information, or the second requirement, is that the ending, so here's the starting point at the origin, the end point is at this coordinate AB, or we might even say that it's XY. You will see both of these throughout the rest of the chapter, quite frankly. So you may be seeing it as X's and Y's or as A's and B's, either one. How do we, what kind of notation do we use for a position vector? Well, you see that we use these pointy brackets, and that automatically means that, hey, this guy starts, it's a vector, and it starts at the origin, it starts at 0, 0, and it ends at the coordinate AB, or in this case, it ends at the coordinate XY. Frequently, our vectors are named with a letter such as maybe U or V or W or something like that. The numbers A and B, represented right here, or even X and Y, are going to be the horizontal and vertical components. So we can see on our picture that our A is our horizontal component and our B is our vertical component. This particular picture, as I've already mentioned, shows the vector. Notice that the starting point of my vector is at the origin. The ending point is at that coordinate AB. A couple other things to point out here is that we have a positive angle, and that positive angle is going to be called the direction angle for our vector. The direction angle for our vector. And we will be calling that theta, so that's quite comfortable with what we have been using for the duration of the semester. Now, if you'll take a moment and take a look at this picture and find the sine of this picture, we know that sine is going to be opposite over hypotenuse. And so that's going to be side B over the length of our vector. So what you have here, this symbolization, I know it looks like the absolute value, but it actually means the length of our vector. So that's what you have there. If you were to isolate B, get B alone, then what we would do is we would multiply on both sides by the length of our vector. So we would have the length of our vector times the sine of theta. We can also do the same thing for cosine of theta, which is going to be equal to adjacent over hypotenuse. So that would be A over the length of our vector. If we isolated A, then this would be the length of our vector times cosine of theta. That doesn't seem like it would be useful, but what I want to point out in this introduction video is that For the rest of this chapter, for the rest of chapter 8, you really kind of have to have two sides of your brain that you're always asking which side are you on and which side do you want to be on. So here's going to be some terminology for the two sides of your brain. Things like legs or A's and B's, X's and Y's, using the word rectangular. All of these, this is going to be one side of your brain. We understand that A's and B's, if we go back to this picture, these are the legs of my triangle. So that kind of makes sense. When it talks about rectangulars, this is often referring to those X's and Y's. So all of these are on one side of your brain. The other side of your brain is going to be the trig side of your brain. So this is going to be the R's and the thetas. It's going to be the polar side is frequently what it's called, or the trigonometric side. And what you want to do is you want to start asking yourself, what is it that you've been given and what is it that you want? Or when I'm in class, I say, what do you got? What do you want? And so really, usually your answer is going to be one of these two sides of your brain. Maybe you're given legs and you want polars, or maybe you're given R's and thetas and you want rectangular. So just understand that you're going to be switching back and forth between those two sides of your brain. So be aware of that. All right, now continuing in our introduction then, let's look at a little bit more terminology. Let's look at the magnitude and the direction angle of a vector. Now, I've already mentioned that the direction angle is that theta that we've been working with for the whole semester. So this is my direction angle. The magnitude of a vector is the length of the vector. And over here, I've kind of shown, and I already mentioned it in this video, but over here I've shown the difference in symbolization. A vector is just going to be named a letter, but the length of that vector, how long it is, which is a number, is denoted by the absolute value symbol. It's not technically absolute value, but that is the symbol that we use for magnitude. So this we would call the magnitude of vector u, or the length of vector u. Understand, please, that the length of the vector can also be named r. We are used to using a radius for this, so often we will also call this r, or we will call it the magnitude of u, or whatever letter that we've chosen. How do we find our radius? How do we find our hypotenuse? Well, we just do that simply by using the Pythagorean theorem. So that's what you have here. A squared plus b squared is equal to our hypotenuse squared. Take the square root of both sides. So that's what you see here. The direction angle is that theta, like I already mentioned. And you can use tangent of theta, which is going to be opposite over adjacent. So that is going to be a common way of finding your theta. Of course, if it's on the unit circle, we won't even need to use that, but we'll go through that in a bit. One more comment here before I end the video, and that is I mentioned the two sides of your brain. And I want to just show you that even these little equations are already separated into those two sides. So notice that the left side of both of these statements, this is the leg side, the rectangular side, my A's and my B's. Whereas here, this is my R's and my thetas, because remember, the magnitude of u can also be called R. And so this side is the R and theta side. So even our equations will often be separated into those two sides as mentioned. Before I stop the video, there was one more gray box that I wanted to point out here, and I point it out now because I've really already talked about it, so I can go through this quite quickly. The horizontal and vertical components, remember the legs of a vector that has this magnitude and this direction angle are given by the following. So here's leg A is going to equal the magnitude times cosine of theta. Leg B will equal the magnitude times the sine of theta. And again, I've already mentioned that up here in this statement right here. And so our symbolization here for our vector might be written in the leg format, but here you could also say that this is the r's and the thetas. So just kind of keep that in mind. All right, I'm going to stop the video here and then we'll come back and do some examples.